Deep in the dark silence of space, a giant blue eye stares directly across 700 light-years of empty void. It never blinks, it never sleeps, and it watches the slow death of surrounding stars with pupil-like intensity. Right now, this colossal cosmic eye is expanding in every direction, stretching its glowing rings of fiery gas into the cold darkness. It looks so much like a human eye that when people first saw high-definition pictures of it, many believed it was fake or a sign from the universe. If you love uncovering the real mysteries of space through simple science, tap that subscribe button and turn on notifications so you never miss a journey into the unknown. Joining our community ensures you will always be the first to discover the universe without confusing jargon. Long ago, people looked up at the night sky and thought the stars were permanent lights fixed to a giant dome overhead. Ancient astronomers spent centuries tracking the planets, mapping out bright constellations, and assuming that the universe had always looked the same. For thousands of years, nobody had any idea that stars were actually born, lived for billions of years, and then slowly died in dramatic fashion. That total misunderstanding of space began to break apart in the early 19th century when telescopes grew powerful enough to spot fainter objects. In 1802, a German astronomer named Karl Ludwig Harding stared through his lens at the constellation Aquarius and noticed something strange. Instead of a single sharp point of light like a normal star, he saw a fuzzy, round cloud of blue and green light glowing in the cold void. He had just stumbled across an object that scientists today officially call NGC7293, though almost everyone knows it by its common nickname, the Helix Nebula. At the time, early skywatchers called these objects planetary nebulae, because through small telescopes they looked a bit like green gas planets such as Uranus or Neptune. But as optics improved over the next 100 years, astronomers realized these clouds were not planets at all. They were something far larger, far older, and infinitely more eerie. When larger observatories took clearer photos of the Helix Nebula in the 20th century, the entire astronomical community gasped at the image. The gas cloud was organized into a central dark core, surrounded by a bright blue-green ring, which was then wrapped in a reddish outer edge. It did not look like a random spill of gas or a messy explosion. It looked exactly like a human eye gazing straight back down at Earth. Scientists originally expected that when a star died, it would either fade away quietly or blow up in a single, chaotic explosion that sent hot gas flying equally in every direction like a round bubble. They assumed space was mostly empty and calm, so any expanding cloud of stardust should form a clean, smooth sphere over time. Instead, when modern telescopes looked closer at the Helix Nebula, they found a structure that was far more complex, layered, and organized than any simple bubble. The gas was split into distinct rings of different temperatures and colors, creating the illusion of an eye socket, an iris, and a dark central pupil. This massive gap between what astronomers expected to see and what they actually found forced them to rethink everything they knew about how stars end their lives. To understand why this matter is so important, you have to look at how a star actually works while it is alive. A star like our Sun is constantly caught in a high-stakes war against its own gravity. Gravity is always trying to crush the star down into a tiny point, while nuclear power inside the core is always pushing outward with incredible heat and radiation. For billions of years, these two forces balance each other out perfectly, keeping the star stable and bright. How incredible is it that a dying star can build a cosmic structure that looks so much like our own eyes? Drop a quick comment down below if you have ever seen a picture of the Helix Nebula before, and make sure to hit that like button to help more space lovers find this story. During the active lifespan of a star, nuclear fusion burns through vast reserves of hydrogen gas stored deep in its core. As hydrogen atoms smash together under extreme heat and pressure, they fuse into helium, releasing enormous amounts of light and heat energy in the process. This thermal energy flows outward from the core to the surface, creating an outward force called radiation pressure. This pressure acts like a giant invisible pillar holding up the heavy outer layers of the star against gravity's crush. For a star like our Sun, this core nuclear engine runs smoothly for roughly 10 billion years without stopping. During this immense period, the star maintains a nearly perfect spherical shape and a steady surface temperature. Earth sits in a cozy location known as the habitable zone, precisely because our Sun maintains this precise balance between outward radiation pressure and inward gravitational force. Every living thing on our planet relies on this delicate cosmic balance that keeps our day sky warm and bright. Eventually, however, the star runs out of hydrogen fuel in its deep core and can no longer generate the outward pressure needed to fight gravity. When that balance breaks, the central core crushes down smaller and hotter, while the outer layers of the star swell up to a monstrous size. The star becomes a red giant, growing so huge that it swallows any nearby planets that happen to be orbiting too close. During this giant phase, the star becomes unstable and unpredictable. The core burns through leftover helium fuel in fast, uneven bursts, causing the giant outer envelope of gas to expand and contract like a giant chest breathing in deep space. These massive pulsations send powerful shockwaves moving through the outer atmosphere of the star, loosening its grip on its own gases. After millions of years in this swollen state, the star begins to experience violent tremors, shaking off its outer atmosphere in giant gusts of stellar wind. Scientists originally believed that this shedding of gas was a quick, one-time event that swept through space like a single ring of smoke. They thought the star just blew its outer skin away once and then sat quietly in the center as a bare core. What they actually found when they pointed sensitive radio telescopes at the Helix Nebula was that the star shed its atmosphere in multiple distinct stages over tens of thousands of years. Each wave of gas traveled at a different speed, slamming into older gas that had been pushed out earlier. This constant smashing together of slow and fast gas layers created dense, intricate shells that stack inside one another, building up the multicolored layers of the eye. This discovery mattered deeply because it proved that the death of a star is not a single moment, but a long, complex story filled with changing weather and violent windstorms. To make the scale of this eye easier to understand, consider its incredible measurements. The main ring of the Helix Nebula stretches across roughly 2.5 light years of space. A single light year is the distance light travels in one full year, which is nearly 6 trillion miles. That means this cosmic eye is about 15 trillion miles wide from one edge of the iris to the other. If you tried to fly a modern commercial jet airplane from one side of the Helix Nebula to the other, the journey would take you more than 2 trillion years. Even our entire solar system, including Earth, Mars, Jupiter, and all the outer dwarf planets, would look like a microscopic dot placed inside the pupil of this gigantic space eye. Yet despite its mind-boggling physical size, the Helix Nebula is actually one of the closest planetary nebulae to planet Earth. It sits roughly 650 to 700 light-years away in the direction of the Aquarius constellation. In astronomical terms, 650 light-years is right in our cosmic backyard, which is the only reason we can see its delicate details so clearly. If it were 10 times farther away, it would just look like a faint blue dot through our best telescopes, and its human-like features would remain completely hidden from human eyes. Did you realize that our entire solar system could fit inside the pupil of this nebula thousands of times over? If that scale blows your mind, take a second to hit the subscribe button right now so you never miss another deep dive into the scale of space. When astronomers first pointed the Hubble Space Telescope at the Helix Nebula in the late 1990s, they expected the inner gas of the blue iris to be relatively smooth. They assumed that gas expanding into a vacuum would diffuse evenly, just like smoke spreading out in a quiet room. They figured that, at high magnification, the iris would simply look like a fuzzy, seamless cloud of glowing gas. What they actually discovered when the first high-resolution pictures came back left the world utterly astonished. The smooth ring was not smooth at all. It was packed with tens of thousands of individual, detailed structures pointing directly toward the central white dwarf star. Scientists counted over 40,000 distinct shapes that looked like glowing comets or tadpoles frozen in mid-swim across the iris. Astronomers officially named these formations cometary knots because each one features a dense, bright spherical head followed by a long, streaming tail. The head of each knot faces directly inward toward the blazing radiation of the central star, while the tail stretches away into the outer ring. These knots are arranged in a massive radial pattern that resembles the delicate fibers and lines found inside a real human iris. The sheer size of a single cometary knot inside the Helix Nebula defies all human imagination. The round head of just one knot measures roughly double the size of our entire solar system, from the Sun all the way out past Pluto. The tail streaming behind that single knot extends across more than 100 billion miles of space into the surrounding dark void. There are tens of thousands of these gigantic structures clustered together to form the detailed iris of the cosmic eye. Each knot sits in space like a giant icy island surrounded by superheated gas. The total combined mass of all these knots inside the Helix Nebula is equal to several times the entire mass of planet Earth. Scientists originally thought these knots were short-lived features created by intense heat evaporating clouds of gas, expecting them to disappear within a few decades. But when researchers analyzed light signatures from the Hubble Space Telescope and ground-based observatories, they realized these knots were immensely heavy and durable. Each knot contains as much physical mass as planet Earth, frozen in a dense mix of cold gas and dust. This structural revelation raised a massive question in astrophysics. How could a dying star create 40,000 individual Earth mass knots inside its expanding shell? The answer revealed a violent physical process that occurs when fast stellar winds crash into slow gas clouds during a star's final evolutionary struggles. When the dying star was shedding its outer layers during its red giant phase, it released cool, dense gas at a steady speed of about 20,000 miles per hour. Thousands of years later, after the outer layers were gone, the exposed hot core generated a much faster wind, traveling at over 60,000 miles per hour. This ultra-fast wind slammed into the back of the older, slower gas cloud with incredible force. When a fast, thin gas wind hits a slow, dense gas wall, the smooth surface breaks apart into sharp ripples and fingers due to fluid mechanics. The dense clumps of slow gas act like heavy boulders sitting in a rushing river of fast wind. The fast wind flows around the clumps, carving them into streamlined, comet-like shapes and dragging gas behind them to form long, protective tails. What do you think is the most surprising thing about these 40,000 knots hiding inside the eye? Drop a comment down below with your thoughts, and tap the like button if you love learning about how space structures are actually built. These cometary knots act as vital shields that preserve the detailed appearance of the Helix Nebula over thousands of years. Without these dense clumps acting as anchor points, the fierce radiation and fast winds from the central star would have swept the inner gas away, blurring the eye into an invisible cloud. The knots hold the inner edge of the iris rigid and defined, keeping the human eye shape sharp and clear across centuries. Scientists studying light waves emitted by these knots have found that the temperature inside the core of a knot is surprisingly low. While the gas surrounding the knots is heated to thousands of degrees by radiation, the center of each knot remains very cold, keeping it dense and solid. This stark temperature difference prevents the knots from quickly dissolving into the thin vacuum of space. At the exact geometric center of the Helix Nebula sits the object responsible for creating this entire spectacular show, located right where the pupil of an eye would be. Scientists knew that a central star must exist, but early astronomers expected to find a large yellow star similar to our Sun, perhaps slightly dimmed by surrounding gas. When modern instruments locked onto the central object, they confirmed it was not a normal star at all, but a stellar remnant known as a white dwarf. A white dwarf is the superdense, crushed core left behind after a star sheds its entire outer body into space. It no longer performs nuclear fusion inside its core, meaning its nuclear furnace has officially turned off forever. The central white dwarf is so incredibly dense that a single teaspoon of its material would weigh as much as an elephant on Earth. It has squeezed about half the original mass of our Sun into a spherical space no larger than planet Earth. Because it was compressed so tightly during the collapse of the star, it holds on to a colossal amount of leftover heat energy. The surface of the central white dwarf burns at a scorching temperature of over 120,000 degrees Celsius. That makes it more than 20 times hotter than the surface of our Sun, even though the white dwarf is tiny compared to normal stars. Its blistering surface blasts out tremendous amounts of high-energy ultraviolet radiation into the surrounding cloud. This intense ultraviolet radiation strikes the cold hydrogen, oxygen, and nitrogen atoms floating in the ring, stripping electrons away and causing the gas to glow brightly. The bright blue-green light in the inner iris comes from energized oxygen atoms, while the deep crimson red along the outer rim comes from hydrogen and nitrogen. If the central white dwarf were even a few thousand degrees cooler, it would not produce enough ultraviolet light to energize the gas, and the entire eye would turn dark and invisible to human eyes. The vivid, beautiful colors of the eye are literally powered by the intense ultraviolet radiation of a dying stellar corpse glowing in the center. For decades, astronomers examined two-dimensional photos of the Helix Nebula and assumed it was shaped like a flat donut floating in space. They expected that if a spacecraft could fly around to the side of the nebula, it would look thin and flat like a shiny coin resting in the dark. What scientists discovered when they combined data from ground-based observatories with space telescopes like the Spitzer Space Telescope completely changed their understanding. By tracking how fast different regions of gas were moving toward or away from Earth using spectrographs, they constructed the first detailed three-dimensional model of the Helix Nebula. They discovered that the nebula is not a flat ring at all. It consists of two giant nested cylinders of gas extending out along a central axis. These two massive gas cylinders are expanding in different directions, but because of a remarkable galactic alignment, one of those cylinders happens to point almost directly toward Earth. We are looking right down the open length of a giant cosmic pipe. It is this exact viewing angle that creates the visual illusion of a perfect, round human eye with an iris and a pupil. If Earth were located in a different arm of the Milky Way galaxy, viewing the Helix Nebula from the side, we would see an elongated, hourglass-shaped cloud of gas instead of an eye. The human eye in the sky is a fleeting visual masterpiece, created by our specific vantage point in space. Does it amaze you that this eye shape is actually a visual trick caused by our lucky location in the galaxy? Leave a quick comment sharing where you're watching from today, and hit that subscribe button to join our growing family of space explorers. Right now, in this very second, as you listen to these words, the Helix Nebula is not sitting frozen in space like a static picture. It is a dynamic, high-speed explosion that is continuously changing and expanding outward into the void. The rings of gas forming the iris are expanding at a speed of roughly 30 kilometers every single second, which translates to over 67,000 miles per hour. That means every hour that passes, the cosmic eye grows wider by tens of thousands of miles. As the gas expands farther away from the central white dwarf, it slowly thins out and loses its density. At the same time, the central white dwarf is gradually cooling down, losing its heat millisecond by millisecond, like a hot coal removed from a campfire. Scientists calculate that in about 10,000 to 20,000 years, the central white dwarf will cool down enough that its ultraviolet radiation will no longer be strong enough to light up the gas. The gas itself will spread out so thin that it will dissolve into the general background dust of the Milky Way galaxy. The giant eye that seems so permanent to us today is actually a temporary cosmic event that will soon disappear forever. On the scale of the universe, where stars live for billions of years, a planetary nebula like the Helix lasts for only a brief moment. We happen to live during the sweet spot in cosmic history when this structure is fully lit up and aligned directly toward our planet. This fleeting nature makes the Helix Nebula one of the most remarkable sightlines in modern astronomy. To appreciate how fast this expansion is happening, think about the distance the gas moves every single day. In 24 hours, the outer edge of the eye pushes farther into space by over 1.5 million miles. That distance is more than 6 times the distance between Earth and our moon. Yet because the nebula is so vast, from 700 light years away, it appears completely frozen to human observers over a single lifetime. As the gas cloud pushes outward, it slowly clears out a giant bubble in the interstellar medium around it. This clearing action sweeps up sparse gas and dust floating between stars, compressing it into a dense outer ridge. This compressed ridge marks the absolute boundary where the dying star's influence meets the wild, untamed vacuum of interstellar space. Scientists studying this outer boundary have discovered that magnetic fields play an important role in keeping the gas organized. The magnetic lines generated by the original star were frozen into the expanding plasma when the outer atmospheres were shed. These invisible magnetic field lines wrap around the expanding cylinders like giant metal hoops, helping to stabilize the eye shape as it travels through space. This brings us to the most incredible and deeply personal realization of the entire story, a fact that turns this distant space photo into a direct mirror reflecting our own solar system's future. For a long time, people assumed that planetary nebulae were rare anomalies that only happened to unusual stars in distant parts of the galaxy. Here is the part of the story that scientists say changes how people view our place in the cosmos forever. Our sun is a medium-sized star, classified by astronomers as a yellow dwarf. It generates light and heat by fusing hydrogen fuel into helium inside its core, just like the star that created the Helix Nebula used to do. Astronomers have run detailed computer simulations of stellar evolution, and they know with absolute mathematical certainty what will happen to our solar system. In about 5 billion years, our sun will run out of hydrogen fuel in its core and will enter the exact same death process that formed the Helix Nebula. It will expand into a swollen red giant, growing so immense that its outer atmosphere will engulf Mercury, Venus, and almost certainly our home planet Earth. Ocean water will boil away into space, the atmosphere will be completely stripped, and the rocky surface of Earth will melt into a sea of glowing liquid lava. After its red giant phase, the sun will shake off its outer layers in violent pulses, blasting trillions of tons of glowing gas and dust out into surrounding space. The core of the sun will collapse down into a white dwarf, roughly the size of Earth, glowing with intense ultraviolet radiation. That radiation will light up the expanding clouds of solar material, creating a brand new planetary nebula where our solar system used to sit. If an alien astronomer living in a distant galaxy points their telescope toward our corner of the Milky Way 5 billion years from today, they will not see Earth or the sun. They will see a magnificent glowing iris of blue and red gas staring back at them through the dark. The Helix Nebula is not just a strange object to look at for fun, it is a direct preview of our home system's ultimate fate. How does it make you feel knowing that our own sun will one day create a glowing cosmic eye in deep space? Drop a comment below with your thoughts on Earth's ultimate future, and make sure to hit that like button if this perspective gave you chills. Every atom of carbon, oxygen, nitrogen, and iron floating inside the Helix Nebula was forged inside the heart of that dying star over billions of years. When the star blew off its outer layers, it scattered those heavy elements out into the space between the stars, enriching the surrounding interstellar clouds with raw material. This process is the primary way the universe recycles its material and seeds the galaxy with the chemical ingredients needed to build new generations of stars, planets, and moons. The gas and dust released by planetary nebulae eventually drift into cold space clouds, where they slowly collapse under gravity to form new worlds. In fact, every heavy element on planet Earth, from the iron flowing in your veins to the calcium building your bones, came from an ancient dying star that blew its body into space billions of years ago. We are literally made of recycled stardust that once formed ancient nebulae scattered throughout the Milky Way. When we look at the Helix Nebula staring at us from 700 light years away, we are looking at the exact same cosmic engine that created the building blocks of our own existence. It is a profound loop where living creatures, made of stardust, use telescopes to gaze upon a dying star that is creating the stardust of the future. Modern space observatories like the James Webb Space Telescope continue to study the Helix Nebula in infrared light, peering through the thick gas shells to see how complex molecules form inside the cometary knots. Scientists have discovered that simple organic molecules, the carbon-based chemical foundations of life, can survive the harsh radiation environment near the white dwarf. These organic molecules ride along on the expanding gas shells, spreading across light years of space where future solar systems might one day condense out of cold gas. This means that as the Helix Nebula expands and dissolves, it is seeding its galactic neighborhood with the raw chemical ingredients that could help form life on alien planets in the distant future. The death of a single star is never just a simple ending. It is a vital, monumental beginning for whatever new stars and planets will be born in that region of space. Understanding this endless cycle of stellar birth, death, and rebirth gives us a completely new appreciation for our place in the universe. It shows us that space is not a quiet, empty vacuum where nothing changes, but a living, evolving ecosystem where every stellar event leaves a lasting mark on future generations. The giant cosmic eye watching us across 700 light years is a powerful reminder of how interconnected everything in the universe truly is. When you look at photos of the Helix Nebula, you are seeing the cosmic circle of life in action. A star burns bright for billions of years, creates life-giving elements deep inside its furnace, and then generously gives those elements back to the universe upon its death. Without planetary nebulae like this one distributing carbon, oxygen, and nitrogen into the galaxy, planet Earth could never have formed, and human life would not exist. The cosmic eye is not watching us with malice or judgment. It is simply shining as a monument to the cycle of creation. It stands in deep space as proof that even in death, a star can create breathtaking beauty that inspires minds across light years. Every photon of light hitting our telescope lenses carries the story of a system that once had a central star, perhaps surrounded by lost planets, now transforming into seeds for future worlds. Astronomers calculate that thousands of planetary nebulae exist within our Milky Way galaxy right now, but most are hidden behind thick lanes of dark interstellar dust. The Helix Nebula remains unique because it sits in a relatively clean region of space above the main galactic plane, giving us an unobstructed view right down its central cylinder. Future space telescopes currently being planned will measure the motion of every cometary knot inside the helix with unprecedented precision. Scientists hope to map how the magnetic fields generated by the central white dwarf interact with the ionized gas, solving lingering mysteries about how these intricate ring patterns are shaped over time. As technology advances, our understanding of these deep space structures will continue to grow, bringing new surprises about how energy and matter behave in extreme environments. Yet, no matter how complex the physics becomes, the simple, haunting image of a giant eye staring back at us from Aquarius will always hold a special place in human imagination. Have you ever wondered what other strange visual shapes are waiting to be discovered in the unexplored corners of our galaxy? Tell me in the comments if you would like to explore more mysterious nebulae, and hit the like button to support our channel's research. When we consider the massive timescale of planetary nebulae, human history seems like a mere blink of an eye. The Helix Nebula began its expanding journey roughly 10,000 years ago, right around the time human beings were developing agriculture and building early settlements on Earth. While human civilization built cities, recorded written language, and invented space travel, this distant cosmic eye was quietly unfolding across billions of miles. By the time the gas shell fades away completely 10,000 years in the future, human technology may have carried our species to distant star systems across the Milky Way. Perhaps future human travelers will fly directly through the diluted remnants of the Helix Nebula, scooping up ancient stardust to power their starships. The nebula that serves as a visual mystery for us today may become the raw energy resource for future generations of cosmic explorers. This deep historical timeline reminds us that we are privileged to witness the universe at this specific moment in technological development. A few centuries ago, we lacked the optical instruments needed to see the Helix Nebula's true shape, and a few thousand years from now its bright colors will have faded into darkness. We occupy the exact sweet spot in human history where our eyes can meet the cosmic eye across the void. Every scientific discovery we make about the Helix Nebula reinforces the idea that space is governed by clear, predictable physical laws that human minds can uncover and understand. From fluid dynamics in expanding gas to nuclear reactions in white dwarfs, the same rules of physics that operate in our laboratories operate across light years of empty space. This universal harmony allows us to feel at home in the cosmos, knowing that even the most distant and exotic objects are bound by the same fundamental principles that govern our daily lives on Earth. The eye in the sky is not a terrifying anomaly, but a clear demonstration of nature's laws operating on a grand, awe-inspiring scale. As space agencies deploy even more advanced space telescopes, such as ground-based giant observatories and orbital spectrographs, our view of the helix will become even sharper. We will be able to track the movement of individual gas filaments in real time, building precise animations of how the iris changes year by year. These future observations will help astronomers refine their models of star death, allowing us to predict the future of our own sun with even greater scientific accuracy. Every tiny detail we learn from the Helix Nebula brings us one step closer to understanding the life story of our own solar system and our ultimate origin among the stars. The story of the Helix Nebula is ultimately a story of connection, transformation, and enduring wonder. It connects our small planet to the vast mechanisms of the galaxy, showing us how the death of ancient stars makes human life possible today. It transforms our understanding of star death from a sad conclusion into a creative process that fuels the future of the universe. And most importantly, it inspires a sense of profound wonder that drives us to keep exploring, asking big questions, and seeking answers about the vast cosmos we inhabit. As long as humans look up at the night sky with curiosity, objects like the Helix Nebula will continue to spark our imagination and draw us deeper into the great scientific adventure. The next time you step outside on a clear night and look up at the constellation Aquarius, take a moment to think about that giant blue eye expanding through the dark. Remember that those quiet points of light overhead are active engines driving the chemical evolution of our entire galaxy. We live in an extraordinary time when human curiosity and advanced technology allow us to photograph these distant structures, decode their physical laws, and understand our shared destiny with the stars. That knowledge transforms how we see ourselves, connecting our daily lives to the grand, sweeping story of the cosmos. If you enjoyed discovering the real science, hidden history, and ultimate future behind the human eye in the sky, please hit that subscribe button right now and turn on all notifications so you never miss another deep journey into space. Leaving a quick like on this video helps our channel reach more curious minds just like yours. Drop a comment down below telling me what space mystery or nebula you want us to cover next, and share this story with a friend who loves space. Thank you so much for watching, stay curious, and we will see you in the next exploration.